All right. So recording also we have started. Message queues, I think we have started that one. So message queues are useful for communicating smaller messages. Shared memory is useful for sharing even larger size data. And message queues, it is a one-time read kind of it. Just like you can send a message, and once you receive the message from the message queue, that message is deleted from the message queue. Whereas in the shared memory, you can store and read the data any number of times without actually destroying the value of that. All right. So these are the like there's some kind of reading there. You can just ignore all that. But these are the four system calls related to message queues. And to use them, you have to include sys/msg.h. To use the shared memory, you include sys/shm.h. To use the message queues, sys/msg.h. These are the four header files that are there. These are the four system calls that are there as a part of it. The very first one again is as usual message get, msg get. So in order to create a message queue, this system call we use msg get of key value. Again, you specify a key. So for any unique given key, right, multiple processes are going to use the same key in order to access the same message queue. And then the flags. And then the flags. Normally, these flags indicate what kind of permissions and do you want to create if it is not there. That kind of bitwise honoring is going to be done. Whereas while creating a shared memory, we must have used SHM get of the key value. But there in that case, shared memory case, you have to define what is the amount of memory that you want to, shared memory that you want to create there. So you have to specify the size of that. Whereas here you are not specifying any sizes. You don't have a choice here because these sizes, the maximum sizes are already fixed. You can't ask for I want this much and all that. Right? Only within that only you can use. So that's why you are not specifying any memory size or message size or whatever, all that. So give only the key value and the message flag. It is much simpler now. And it returns naturally a meaningful positive integer if it is successful. If it fails, -1 is going to be returned. That's all. After creating a message queue, now we can use that message queue to send a message to that or to receive a message from that. To send a message, we use this particular system call MSG SND. Right? MSG SND. This is the system call that we use. For that, naturally, you have to specify like the first one is the message queue ID. Whatever the ID that is returned by MSG get, that number you have to use there. That I think all of you understand. The second one is the what is the message that you want to send? Corresponding pointer, starting address. Starting address of the message that you want to send. You have to specify. And also you have to specify the size of the message. We'll come to that once again. Starting address of the message and then the size of the message. And after that, the flags. Flags by and large, these things are going to be 0 in general. Whether you want to wait or you want to just come out of that even if it fails. So there are some standard. Majority of times you are likely to use 0 here. That is the message sent. Similarly, message received. Message received. So in this case, like again, you have to pass on the message queue ID and then the starting address of the message pointer, right? So where exactly you want to receive and store it, its corresponding starting address. And then what is the maximum size that you can actually receive? Because you are not trying to receive a message. To receive a message, you must have already allocated the memory space. So you have to specify then what is the maximum message that you are capable of receiving. That size you have to specify, so that it's not going to damage your data and all that. So specify what is the maximum size of that particular. And then the next thing is message type. So just now we said within the message queue, it maintains a number of smaller queues, in fact, attached with different message types. That means number. Message type means it's a number. Based on that number, like while receiving, you can ask for which message are you interested. The sense it's first in, first out. Remember that. That means whatever is the first message that is sent into this message queue by any other process, that is going to be the first that is going to be get out of that. But then instead of having overall a single queue, it maintains multiple smaller queues with corresponding message type. You can ask for from this smaller message queue, from this smaller message type, like I want a message of this type. I want a message with message type equal to 100. Then within that 100 message type queue only, it's going to retrieve the message. So you have a choice now. Either you can ask for from the entire message queue, whatever is the first one that is there in the message queue, you want to retrieve that. Right? From all the message types, you want the very first one, whichever is there. That is one kind of mechanism. The other one is you want to retrieve or receive a message whose type is equal to 100. Meaning that if there is a message with 100, only that particular thing from that particular queue only it returns the very first one, first in, first out kind of thing. So that choice is there for us. So the other one is, in fact, sometimes you can retrieve the first message or like whose message type is anywhere less than or equal to 100. Something like that also is possible. Either exactly equal to 100, that particular thing, or anywhere across all of them, the first one, in which case normally you specify 0 here. Message type equal to 0 means from the entire message queue, the very first message that is stored in there. If it is greater than 0, then only that particular message type only you are interested. If it is negative, like minus 100, then the meaning of that is it's going to return a message whose type is anywhere less than or equal to 100 actually. Whenever you say minus 100, so it returns message types whose value is less than or equal to 100. Either 100, 99, 98 or right up to 1. So you can't have a message type equal to 0 actually. 0 has a special purpose. As we just now said, whenever message type equal to 0, it retrieves the very first message that is stored into the message queue across all the message types. 1 means only from message type equal to 1, from that small queue only it's going to return. So that is as simple as that. And then the message flag, all that. So MSG get, MSG send, MSG receive, right? And then MSG CTL as usual. Most of the time we use MSG CTL controls. We use normally to remove the message queue. Remove the corresponding IPC object. Right? So the syntax is message queue ID, first parameter, command. Right? Already even in the shared memory we have seen IPC underscore RMID command. Right? Whenever you use that, it's going to be removed. Right? Command and then the corresponding like structure pointer. In this case, it is a structure pointer whose structure name is message queue ID underscore data structure. DS stands for data structure. Shared memory also we must have seen shared memory ID dot underscore data structure. Right? whatever is the data required for operating this particular command will be available within this particular structure point. So this is what it is, and naturally we can see all these explanations. MSD get we have already seen, it is very simple. In order to send this, now that you're actually talking about you want to send a message and all that, you have to, just like we have created a shared memory structure, the one that is to be shared across processes, you have to also create a message queue structure on your own. Message queue structure on your own, because you don't, like the IPC fellows don't know what kind of data you want to send and receive, right? It's not necessarily always only the text message. It can be any other number, a structure can be sent, or anything can be. So that's why what they have said. So you have to create a structure to begin with, whose first field should always be message type. This is a condition. Here you are talking about message pointer, and this message pointer is going to be it is likely to be a structure kind of thing, right? Always remember, it's likely to be a structure pointer, wherein the structure's first field is always going to be a long integer. Is always going to be a long integer. This name can be anything, whatever name that you want to use, you can use, no issue, right? And here in this case, you are using message type. And after this, whatever data that you want to really send and receive is going to be there. So this is very, very important. The structure of the message is constrained in two ways. First, it must be smaller than the system limit. Second, it must start with a long int, which will be used as a message type in the receive function. Right? That message type is going to be picked up from this particular structure. When you are using message, it's best to define your message structure something like this. Because the message type is used in message reception, you can't simply ignore, right? You can't simply ignore it. You must declare your data structure to include it. And it's also wise to initialize it so that it contains a known value. The first parameter, message queue ID, is a message queue identifier. The second parameter, message pointer, is a pointer to the message to be sent, which must start with a long int type as described. So naturally, the starting address of this particular structure must be passed as a parameter to this. But then what should be the size of this message? Unfortunately, the size of this message is not exactly the same as the size of this, but it is actually size of the structure without the first field. The size here, what you are actually talking about, is the size of the complete structure minus size of the first field. That is, because the remaining is the actual data that you will be sending and receiving. This field message type, you are only using it to distinguish between different types of messages. So that's why the third parameter, message size, is the size of the message pointed to by message pointer. This size must not include, remember that, must not include the long int message type. Right? This you should remember. The size must not include the long int, except for this remaining. There can be any number of fields of your choice. It's up to you. No limit on that. Limit is there on the overall size. But you can have an array of integers, or you can have an array of characters, or you can have multiple fields here. Right? It's up to us. No issue. The fourth parameter, message flag, controls what happens if the current message queue is full. Right? Because there is a limit on the amount of data that you can store into the message queue. If that is full already, just like you already studied in data structure, if the queue is full, what do? You will have to wait. So that if some other process is there which is going to remove one item, then a place will be created. You can go on in that particular manner. So if the message queue is full, so what is to be done? Do you want to wait or do you want to return a kind of a failure case to you, right? So that you can actually define as a part of the flag actually. IPC, there is a constant called IPC, no wait. You don't want to wait. So if let it return -1, then you understand that, oh, so you are unable to send a message, right? Whatever. So that means it can be either a blocking one or a non-blocking one. At the end of it, the message send returns 0 if it is successful, -1 if it is failed, right? So whenever it is successful, what it does, it is going to copy your message data into the message queue, right? It's copying whatever data that you are passing on, whose starting address is actually is being passed to that. You are passing on the starting address of the structure. And this data at the end of message send is going to be stored into the message queue that is maintained within the kernel, in fact, within the kernel memory and all that. So it is as simple as that, message send. Receive also same thing now. But while sending, where are you storing the message type? You are storing the message type as a part of the structure itself. Remember that. You are not including like a message type as additional parameter here. Message type is stored as a part of the structure, message structure itself. And that is going to be picked up by the message received. But now the message received, like here, the syntax is slightly different. Message QID, pointer, then what is the size of that, and then you are also specifying the another parameter called what kind of message you want to receive. 0 means any message is good enough. But remember, message queue means it's going to always pick up the first in, first out, right? By using that particular mechanism. So when you use 0 across the entire message queue, first in, first out. When you use a positive number, then only within that message type of that particular number only is going to be picked up. If nothing is there in the message queue with that number, then it is going to make to wait. So that other process, whenever it sends, probably it's going to receive it. Right? It will be made to wait. It is a blocking one. Or you don't want to wait there, that is controlled by this message flag. Do you want to wait or do you want to get out of it? Right? So that is controlled by the message flag. And again here also, this message size is going to be size of the structure minus the size of that long integer value. Same thing. You have to actually use. So this is about the system calls. Message control, if you see, MSDCTL, ID, and then the command. Command can be one of these things. IPC_stat, IPC_set, command can be, or IPC_RMID. One of these values is going to be specified. And then whenever you want to modify the permissions and all that particular thing, the corresponding structure, struct message QID_DS, struct. What are the fields within that particular structure are the following. Struct message QID_DS. So user ID can be modified, group ID, permissions, and more permissions and all that, right? User ID of that particular message queue can be changed, group ID can be changed, or permissions of that particular message queue can also be changed. These are the parameters. These are the fields within that. Normally, we use all these things with respect to IPC stat and IPC set. So whenever you use IPC stat, then this structure is going to be filled with these details from the existing message queue. Whatever the existing permissions, all those things are going to be filled into this when you use IPC stat. You are getting the details. Whereas you first initialize this data structure and then use IPC_set as the command. Then with these permissions, you are changing the message queue with those details as a part of it. RMID, nothing. Right? It's going to simply remove the corresponding message queue as a part of it. So here you have like two programs actually, message1.c and message2.c, right? So two programs are there. Essentially, you can think of as if it's a kind of a client server model. So client will actually read the data from the user, and whatever the user types in is going to be sent to the message queue, so that the server will receive the message from the message queue and print the value. So that's the kind of program that this book is actually talking about. Now let us go into the details. Include all the necessary header files, right? And include the sys/msd.h. Struct my message underscore st. Structure, my message structure. That's what it means by. And already, as we said, first parameter, you don't have a choice. You have to specify long int. Long int, my message type. This field name can be anything, but it should be of type long int. Because the receiving end, like because you will be sending the starting address of this entire structure. So it always expects the long int to be available at the beginning of that entire big structure. And after that, your data, whatever. In this case, he is actually sharing an array of characters, some text of buffer size, right? So this is a structure. So this kind of data is going to be sent or received, whatever, depending upon the situation. So int main, and then int running equal to 1, int message QID, MSG ID, struct my message structure, some data, right? Long int message to receive equal to 0, right? Some variables he is declaring. You will get to know naturally. So the very first thing is message QID equal to message get of some key value permissions IPC create. You can easily understand this. There is hardly anything, right? So it is returning the message ID. And whenever it is -1, it has failed, you are terminating the program. Straight away, no issue. If it is successful, then it returns -1, right? So some meaningful positive integers. So if everything is okay, then we have to go into a loop. So this is again like communication, conversation will go on until you type end kind of it. Until the client actually sends the end to this, then server is going to terminate whatever. So now as you can see, while running. So because you are receiving here means that this is a server program actually. This is a message queue server, which receives the text sent by the client. So while running is already initialized with 1 there. So forever loop kind of it. And it will be running value will be changed once you receive the message like end as a message kind of it, whatever. Let us see now. So now what is to be done? The first step is receiving. So you are doing that. Message receive, message QID, comma, void store, because that's what the what it is, a signature ID is. And you have to receive into what? Receive into structure, whose variable name is sum underscore data. You can see that sum underscore data is what? This is the one. Sum underscore data. Whose the data type is the structure that you have declared. Struct my underscore message underscore data. What fields are there in this? The first field is the long integer, second field is anything of your choice. Any number of fields you can have. So you are passing on the starting address of that particular thing. And after that, you see, you have to specify the size. But the size now should not include the entire size. It should include only the actual message that you are actually sending, without considering that long integer. And if you take a look into, which is the structure, right? And what is the size of the actual message? This is the one. And already you said buff size. So that's the reason why you are passing on buff size to that particular thing. This is the size. The total size of the entire structure. You have to exclude this long int. So that's why this buff size is actually given here. So of size, comma, and then what kind of message you want to receive. Here he has actually developed a very simple client-server mechanism, like no consideration for message type and all that, actually. Right? So message type, message to receive, if you see here, this is the variable he is actually using. And it is already initialized with message to receive is equal to 0. And already we said whenever you use that 0 as the message type while receiving, it is going to receive the first message that is sent to the message queue. So at this point of time, first in, first out, right? So whatever is the first one that has come to this is going to be written. So that's why you can also specify 0 itself here. You don't have to declare a variable for that, especially for that and all that. Not required in fact. But anyhow, so you have specified that. So message to receive here. You can as well specify a 0 in this particular. And the last one is 0, flat, as we said, always 0, many a times. Now he is comparing whether this message received is successful or not. So he is now whether this is double equals minus 1. If message received returns minus 1, that means it has failed to receive. For whatever reason, maybe the message queue itself is not there, or any of the other reasons, like you are actually specifying. If it is minus 1, what to do? You terminate the program. Right? Because once it fails, probably next time also it will naturally fail. That's why you are terminating by giving appropriate message there and all. So here you are also displaying the error number. What is the reason behind and all that. Instead of using fprintf, you can also use p error. Right? You can use p error of this message received failed with message received failed. That is good enough. P error if you use. Exit of exit failure. Over. If everything is successful, if this message received is successful, that means the data is now available in that particular some data structure. Right? Into this structure, the data must have been received. Now you can print it. It is a server now. The server is going to print the data that it receives from the message queue, which is probably sent by the client program. So you are only printing here. Printf, you wrote %s. Some data. This is the field structure, right? Variable dot. So what is the one that contains the data? Some underscore text. You can see there. This is the one we are actually talking about. The message received at the end of that, it's going to place the data into this particular field. Some underscore text. Actually, it's going to copy all the data into that particular thing. You can have any number of other additional variables as well. The message received has no knowledge about what kind of field names that you will be using and all that. What all that it knows is a starting address. Whatever that comes is going to be copied as it is into that particular starting address area. Only your program knows what are the fields within the structure, how to access that data and all. Right? It's a more generic one. So here you are specifying some data dot some text. That's basically printing. And also now for how long should you, so you are trying to compare whether you have received the end string or not. So if strn compare of some data dot some text comma end. Is it? That means how many? The first 3 characters. You are only comparing the first 3 characters. Yes. After that, yes, it may be anything. Even if you send ending or ends. So whatever. You type anything that starts with n. So this strncmp compares only not all the characters, instead n characters. That n is supplied as a parameter here. Right? So if this is equal to 0, both of them are matching. So now you want to terminate the program. So running equal to 0. So that next time it goes through the loop, it will terminate the loop. Curly brace closes, curly brace closes. So if it is not equal to end, it will go back again, receive another message, and print that message once again. Print that, prints on. It's a very simple protocol here. Server is continuously trying to receive a message from the message queue. If at all anything is sent by what? Sent by the client. That's all what it is. There is hardly anything actually, except that because somebody else has developed all these system calls and all that, you have to go through the names of them, how many parameters, what is the significance of the individual parameters, all that. So once you understand, then it is much simpler. So at the end of that, you try to remove the message queue. So how do you remove it? By using MSGCTL. So if MSGCTL MSGID, command name is IPC underscore RMID. And then the 0. The next one is 0. Because for removing, you don't have to supply anything. So the next parameter value is going to be 0. So if this is -1 for some reason, it has failed to remove it. Otherwise, it is successful. Whatever. At the end of that, you say exit of this. That's all. This is a server program which is continuously receiving the message. Similarly, you will have a client program which will read the data from the user and then send that particular data to the message queue. That's all what it is going to do. So here, this is the second program, which we call it as the client program. Include all the header files, right? All the header files, whatever are required. And then, as defined, like he is basically assuming that the maximum data that you would like to send is 512 bytes. You can also change it. There is no fixed thing like this. So here, right? So long in here also, the structure must start with long integer. And after that, it can be anything. Right? It can be anything. So this structure can be different from the other structure as long as you are able to communicate is good enough. Fields and all that must naturally be same. Okay, so int main, int running equal to 1, structure my message, some data, message ID, character, buffer of this. Why do you require this? You are going to use this buffer while reading the data from the user. User is going to type from the keyboard. Whatever that you are typing is going to be stored into this particular buffer. And then from this buffer, it's going to be stored into this some data. Instead of storing directly into that structure, you are storing first into this and then from here into this, and then you are going to send the message to the message queue. That's what you are going to do that. So simple again. How do you create that message ID, message get off? Same number, permissions, IPC create. If it is equal to -1, failure, while running, right? Forever, again. Now, because this is a client program, client is going to read the data from the end user. So you are now displaying the prompt to the user. Printf of enter some text. So and then how do you read the data? Fdata of buffer comma, not more than this many characters from the keyboard, standard input. You are trying to read from the standard input, not more than this many characters into this particular, right? And then, because we are not distinguishing between the message types and all that, so for that, all the messages that you will be sending is of the same type. And what type it is? Message type equal to 1. You are specifying always. Here, when you are sending the message type is 1. Whereas while receiving, in the message received as a parameter, you are specifying 0. 0 doesn't mean that you are receiving message of type 0. You are receiving any message. You are receiving any message. Right? So that's why you have to understand that. So here you are specifying some data dot by message type equal to 1. This number you can give any number. Still it's going to work, remember. But not equal to 0 anymore. 0 is not a valid message type while sending. You can give any other number like 100 and so on. Now after doing that, what are you doing? Because you have already read the data into this buffer. Now you copy this buffer data into the structure. So strcpy of some data dot some text comma buffer. You're copying this buffer value into this buffer. After copying, That means you have initialized the actual text as well as the message type also you have initialized. Now it is ready. The structure is ready in order to send it. So you can send it now. If message send off, message QID comma, specify the starting address of that structure. Ampersand some underscore data. And then what? You have to specify the size of the structure that you are actually sending. But while sending, again the size of the structure is the size of the structure minus what? That long integer. That's why if you see here within this is the actual message size, max text, right? This is the maximum. That's why you have to specify max underscore text. Max underscore text. Here, max text. And then flash it here. If you get -1, it has failed, you display the error message. If everything is all right, then you are now comparing whether you want to terminate or not, as usual. If strn cmp of buffer, comma yet, comma 3. Right? Now you are comparing the value that is there in the buffer. You have just now read from the user. So then running is 0, so that the client will terminate. Once the client terminates, and you are also sending end there, server also understands, that will also terminate. That's all, exit at the end of that. So it's a very simple program. So now message 1 and message 2. So enter some text, right? Hello, this is the one, and how are you today? And then yeah. So this is the message 2 is the client program. Message 1 is the server program. Yes, ma'am. So first hello, so first hello, how are you today? How are you today? And then end, and both of them will come. That's all. It is as simple as that. Now you can take a look into our actual right. So this is a message 1.c, which is a server. Same program, I have just copied it here into this and make small changes here and there or whatever. There is hardly anything, almost it's the same program, right? So you also can actually do that. And just now we said that this message to receive variable may not be required. You can directly put a 0 there if required, no issue. So all those little changes you should be able to do, appreciate, understand, and then try on a system. Similarly, message 2.c here, right? So this is also there as a part of that, and so on. Let us run this program and see what is going to happen. So I have just purposefully created 3 windows here, right? So what we shall do is the following. Probably this is one client. All right. So let me change the directory now. Change directory to np/ipc. Okay, so we are there now, right now. ls is displaying all of them, it's okay. So we will create now what? One client program here, probably, or // message q1, right? Message q1, ms g1, and then run it like this. Okay, so it's running the first one. Here also, if you want, you can actually run the same message 1 if required. No such file or directory msg1, right? Because we have not changed the directory as such. IP. This is the one, it's running there. Message 1, message 1 is a server actually. Normally, you can have multiple clients and one server kind of thing, right? So, whereas 2 servers are now doing, let us see what is going to happen. change this to IP followed by question mark, then run the message to 2. And this is going to read the data. Message to MSG probably. Right. So it is asking for the data now. So just let me put line 1 kind of thing. So which server is going to this thing? Like as you can see, this fella could actually get the time. So you are getting, you wrote line 1. You wrote line 1. So then line 2, let us see. See, that fellow has got it. It all depends upon who is getting the what it is, the CPU time. So that fellow is going to get the corresponding thing. So when you are running multiple servers, they are all connected to the same message queue. So now line 2 will no longer be there on the message queue. So whatever the other one that you are likely to type in, you have not scheduled. It can happen on anything, in fact. So it so happened now from one here, one there, one coming to this particular point or whatever. So it doesn't mean that only that way it has to happen and all that. Right? So you say hi, and then one more hi. Right? So it's going on in that particular manner. So just simple enter is going there, power is there, and then you say end. Now end is a problem. The sense that the moment you say end here, so one of the, as you can see here, this fellow has come out of this, right? All of you understand here. So the client has got out of that, no doubt. But this end's text is actually received by this particular server, and he also got out nicely. But this fellow is actually waiting. He is trying to receive it, you see. Whereas the message queue itself might have been destroyed by the client, right? So there is no longer a kind of thing. That's why message receive failed with error 43. You can find out what is the error 43 means and all that. So normally that's the reason why normally you use P error. If you use P error, you get even what is the reason behind. Instead of error code, you will get error message. Remember that. So there are other commands here. Just like you have ls command to list all the files, you have a command to list all the IPC objects. List all the IPC objects. There is a command called IPCS. Right? The command name is IPCS. IPC status, that's what you mean by file status, ls means, right? So IPC status, give me all the IPC status of. So if you are interested only in the message queues, then you specify the queue here, right? So so nothing is there at this particular point of time. But let us actually run the same program once again, then you understand what is going on. So let me just clear the screen here. Then you will understand what we are going to do that. Right now, you don't have any message queues and all that, because at the end of the client is going to remove that. So that logic we have put. So that's why. So this is going to be there. Now we will run one server here, one client here. Right? Server is MSD1. Client is also /MSD2. Enter something. Now the message is already there. Now if you see IPCS -Q, you can see here as a message queue. This is the key value. In a hexadecimal value, it is actually displaying the key value. What is the key value we have given? 1, 2, 3, 4. You convert this hexadecimal value 4D2, you should get that number what we have already given. 1, 2, 3, 4, whatever. And message queue ID equal to 1, right? Message queue ID is 1. Owner is TSR. Permissions are 666. User bytes, no bytes are there at this point of time. No messages. Now you enter something here. But it is difficult because the moment you enter here, it's going to be consumed there. So, but still, let us see like what is going to happen. Line 1. You can see there line 1, you wrote line 1, whatever. So here again, you can probably find out. So you are getting the same thing, because whereas if you give some kind of what you call delay here, so that it's going to send the message, but there is some delay before receiving. At that time, if you use IPCS here, you will find even how many messages are there and all that particular thing. In fact, we can try that. It's not that difficult. We can even we can do that particular. So both of them have terminated. Now what we shall do? We'll run this first to begin with, and then say hello, right? And then say hello. So it is already delivered, right? So now if you see here, IPCS minus Q, you can see here there is one message pending, and user bytes is 512 bytes. 512 bytes are there because 512 bytes is the size of our structure that we have already defined. Even though this actual data is little, but the overall structure size is big enough. So if you type once again here, hello Rom, something like this. So 2 messages have gone. Now if you see here in this particular panel, you have 2 messages. You can create the server now so that it's going to consume one by one. Right? It's going to consume one by one. So you can see here both of them have come. Now if you see here in this particular thing, you have 0 messages and 1. So like this you can you should be able to understand, spend some time what's happening there and how to and all that. So in this case, the client server model, what is happening is only client is sending the data. It's not coming back. If you want whatever data that you are sending, you want that data to be processed and give a reply back to the client, right? In a client server model kind of thing. You should be able to design it so that server will first receive the request, do the required processing, and then send the reply back to the client. Send the reply back to the client. So that should be possible, right? Without having any difficulty. Similarly, client also must read the data from the user and then send that data to the server, wait for the reply, and then receive that reply and print it. So that entire complete cycle must be done, right? So you should be able to write that particular program without having any difficulty. Let us now take a look into that particular approach, where I have actually modified all that and then have a message server and then message client, 2 programs. You have to write down 2 programs. Now there may be many clients and one server. So how do you distinguish like the replies should go back to the same client? Because if the client actually try to receive the messages, whichever client executes the message received, he is going to get the corresponding response. You are likely to mess up all that. For that reason, you have to choose appropriate message types. So in this case, what you are doing is you are using the process ID. So we use the process ID to distinguish messages of different processes. Client, whenever it is sending the message to the message queue, it is going to send its own process ID and also the data. The process ID and the data is going to be communicated to the server, right? On one particular message type, maybe message type equal to 1. Message type equal to 1, the server will receive all the messages from different clients, right? They will all come to the same message type equal to 1. But within that message, you will have process ID, that means client's process ID, and what is the data on which you have to like give a reply or whatever. Then while giving the reply back to the client, what server has to do? Server will give a reply back to the client on that particular message type whose process ID is equal to so and so. So you use the process ID as a mechanism to distinguish the replies of different clients, right? So the client will only pick up its own reply because it knows its own process ID. It asks for that particular process ID message type, right? So that's what we are going to actually do that. So for example, message client is there here. Let us examine this particular thing. Make some effort to understand this particular thing. So all the header files and then some max text or whatever. Now our structure, we are changing the structure. So first field is as usual long integer. Now we are adding one more field called process ID. And then the actual data. And then the actual data. Whatever. So in this case, again, we are actually trying to read the data from the client, and then its data will be sent to the server. Server will convert that into uppercase. That is a simple service. Convert that into uppercase and again give it as a reply back to the client. That's what our idea is basically. Remember. So you have this character array and you also have the process ID within this particular. So size of the entire message is to be given as the entire thing minus this particular thing. That's nothing but the size of this array text plus size of this process ID. Either way. Now let us actually take a look at it. This is a client program we are actually talking about. Client program we are declaring. So you can see int main running equal to 1. Int process ID you are declaring a variable. And then you declare a variable to hold the entire message structure. Right? You are doing that. And message ID. And then you try to read it into the buffer. Now, how do you know what is the process ID and all that? Already we have talked about. There is a system called get PID. So PID is equal to get PID. So you have got the client get its own process ID and that is available in this variable. Now after that, create a message queue by doing all this. I hope all of you understand. Now here, if you want, we can also use something called PRL. Now this person D, all this is not required at all. These things will take care. This is a much simpler mechanism. Okay. So whatever is there as a part of it. So while running now and all that, so you can see printf here while it's prompting the user. It is displaying the process ID also so that you can verify, right, whether this data is received by the server or not. So person D enters some text, comma PID. Now you try to read the data. And then, so you want to send it. So whenever you are sending your message type, you are putting it to be equal to 1. And then there is one more additional field. So some data.pid equal to PID. Right? So you are sending client process ID also as a message to the server. So that server can distinguish the replies by giving the replies with that particular message type. Client also, while receiving, it will receive only of that particular message type. So it is as simple as that. Now you copy it, strcpy of some data some text comma buffer. And then if message send out, now you want to send the message. MSG ID, starting address of the structure. And then what? What is the size of this thing now? Size of this is this max underscore text, which is the size of the array, plus size of PID. Because PID also is a part of the like message now, part of the message. Only you have to exclude that single number. long integer, first long integer. Okay, so size of process ID, comma 0. If it is equal to -1, there is a problem there and all that. If you want to, you can just simply, as we said, clear that. Right, message sent failed. So and then exit, whatever. After sending it once, you have to naturally receive it, right? Immediately. You must receive the reply. How do you receive the reply? If message receiver, message ID, comma, again you are trying to receive into the same structure, right? Ampersand that. And then what is the size of it? Size of it is, right? Buff size plus size of PID. So buff size plus size of this thing. Like, so why is that he is actually using buff size? So buff size is not appropriate. While receiving now, you are going to receive this entire thing, buff size. So first, get as a buffer, right? You are reading that, and then you are sending this entire thing, and now you want to receive it back. So that buff size and what is max text? Max text. Character buffer size, that's okay. Into the buffer, it has got its own size. Max text is 512 anyhow, no problem. Ampersand some data, all that. So actually, this can be max text only, strictly speaking. It should be the same structure, right? So this should be the same thing. So here, this should be max text. Max text is more appropriate. Definitely. So whatever is here, because it's the same structure. So right. So this is more appropriate. Max text plus size of PID. Comma. Now if you examine the next parameter is important. While receiving by the client is now receiving. Client is receiving the reply from the server. You are not interested in any kind of message type. You are interested in receiving your own replies. Your replies, this client's replies, are going to be placed onto message queue with message type, whose message type is equal to its own process ID. That's why you are specifying here PID. Remember. Then the client will receive its own. If there are multiple clients, each client will receive its own reply, not somebody else's otherwise. That is very, very important. And then the flash is 0 here. These things as usual, I will just leave it as it is. Now print up from the server now. Right? You have received from the server. What is that you have received? You are printing here, percentages and whatever. So it is actually specifying that. So probably you can see a new line. Right. So some data, the modified version you are likely to get. And then compare as usual. If it is equal to, if it is that, you try to do whatever. Buffer value we have not modified. Buffer is the one into which you have read the data. But you have sent the what? You have sent that into the message queue and then you have received it. So not modified. Remember that. What is modified is this particular. So you compare with the end, whatever, all that. So this is a client actually, right? All of you must have understood that it is a client program. Similarly, server will first receive and then send the reply. Right? So that's the only thing. So include all the header files and declare the message structure, right? All that. And so here he is putting like we are putting 512 or whatever, not required, max underscore text you can put or whatever, no issue, right? So int running equal to 1, message ID and process ID, struct my message underscore st and some data, long int message to receive equal to 0. So server, whenever it is receiving with message type equal to 0, meaning that anything that is there on that is going to be retrieved by this particular thing. So message received, strictly speaking, it should have been 1 in fact. Like it should have been 1. Like actually, let me see here. Client is there. In the client's thing, what are you doing? You are initializing the message type equal to 1. Clients are always putting their messages with message type equal to 1. So it is appropriate for the server to receive the messages of type 1 because there are other messages as well. So of different types. The server should not read those things in fact. So we'll look into that. We'll look into that particular matter. This is not relevant now. Strictly speaking, I can even remove this particular thing. Int I some local variable and all that. So message get off all this, right? Whenever it is there, and then straight away running while running. Message receive off now. Message ID, some data, buff size plus size of PID. Is it buff size? Some data, how did we declare it actually? 512 we put. Right? 512 we put actually. This is not correct. Max text is appropriate actually. Max text is appropriate. Here, while receiving. Here it is there. Max text plus size of PID, comma message to receive. See, server now is supposed to receive the message whose type equal to what? Whose type equal to 1 actually. Because we are now assuming that all the clients are going to send their request whose message type equal to 1. So that's why server is exactly trying to receive only those messages whose message type equal to 1. So that's why 1 is more appropriate. Right. And after that, as usual, so you wrote here the server is now printing here whatever is the end user is sending actually. You wrote percentages and some data dot some text. And your process ID is, because while receiving here, you are not only receiving process ID, you are also receiving the text. Because that structure now contains all the other fields. That's why you are able to print what? The server is able to print process ID of the client, which has sent this particular text actually. Just for your confirmation, you are actually printing all those details. Some data dot some text, some data dot PID. Now you have to actually give a reply back. While giving the reply back, the message type must be now of this particular process ID. That's why you are now changing it. Some data dot my message type equal to some data dot PID. Now server is about to give a reply with a message type matching the process ID. So that only that particular process is going to get its reply there. So, and also what this fellow is doing is server also is just simply sending server's process ID. So you can see some data dot PID equal to get PID. It is a server now. Server's process ID also you are sending. But after that you are processing. What are you processing here? As you can see, you are now converting all the characters into uppercase. So for I equal to 0, as long as it is not null character, some data dot some text of I, meaning that it is not a null character I plus plus. To modify that, some data dot some text of I equal to upper. It is going to convert a single character into uppercase, to upper of some data dot some text of I. This is a conversion mechanism. String uppercase conversion. You are doing that. After converting this, now you are sending the reply back by giving MSG send off message ID, starting address, what is the maximum this thing, the size of the structure, max text plus size of PID, and then comma flags is here. Right, simple. You are receiving the request and then updating the fields, modifying the text, and then sending the reply with appropriate message type. And then here comparing whether to quit or not, right? If you are specifying that particular. Actually, now quitting is not appropriate. You want the server to be available all the time, right? So server should not do this. We can remove this particular thing in fact. The only trouble is going to be client should not remove the corresponding thing. Then it's going to be okay. We can see here now, like strncmpr, all that particular thing. Yeah, some protocol is there. Like probably for the time maybe we can even leave it. No issue. So at the end of it, message control, IPC RMID. Okay. Removal is there in the server now. Is the removal is there in the client? If the removal is not there in the client, then we can retain it. I think updating this is more relevant now. So this you can remove it now. Server should be available all the time. So you are removing this particular. Okay, so it is sending the reply back, and again it goes back. Right, it goes back. It is a forever loop actually while running. It is a forever loop. And then at the end of it, in case you want, which is not going to happen, so it's there as a part. I hope all of you have followed it, what we are actually talking about. It is another simple program. Now we have to compile all of them. So this is the thing. Now let me compile the programs. Okay, so this is the server compilation. So server code is compiled. And then similarly, client also you have to compile. Client also compiled. So both of them are compiled now. Now we don't require this. Can go. Still it's going on. MSD1 or MSD2. These things are not end probably. Okay, so now server and client mechanism. Okay, so we can run the server here. Let me run the server in the below model. /MSD server. Then run it. So server is running now. We can run one client from here. /MSD client. See, I cannot type it, so I'm just giving this particular map. See there, 5436. Process ID of this is 5436. Here also we can run one more client. /MSD another one. So its own process ID is 5443. Server is running here. Probably here I enter like line 1. See there what has happened. Line 1 you have entered, and after that client has sent it and again try to receive it. From the server it has got line 1. So this reply should not go to this client. This reply should come to this client. Right? So 5443 enter something. And here if you see you wrote line 1 and your process ID is 5443. That's why it is able to send the reply to it. So you give again once again one more of this thing here. Right? So hello is there, hello has come and all that. Now by any chance you give from this particular thing, by kind of it. So you see from the server by. So it is able to get that because 5436 you wrote by and your process ID is 5436. So server is able to distinguish messages from different clients and giving replies to different clients in their own message types. So there is no mix-up as such. So you can always type in whatever that you would like to. So ROM and ROM is actually that particular way. It is actually highlighted. So wonder is kind of it. So you are hitting that particular thing. And then code, something like it. So any number of clients now can actually talk to them. Can actually talk to power is there, 5446, like this. So this fellow now can end the communication. So only this fellow has end, from the server it has got, but server is still running. So we should be able to continue the conversation here by running this particular thing. Or still is giving the reply back, or PVP, whatever. And this fellow also gives end. So still, so no clients right now, only server is still running there as a part of it. So you can in fact find out here IPCS, that particular command. IPCS. And then minus Q, right? Message queues. Minus Q means message queues. Minus S means semaphores. And minus M means shared memory. Remember that. So right now, all those things are there, but this is what exactly it is. 0 messages, 0 bytes, and all that. So now we can terminate this particular thing by doing like this. So now also it will be there because you have terminated the corresponding thing. The message queue is there right now. So all the programs have already terminated, but the message queue is still there. IPCS minus Q, this is still there as a part of it, as you can see. Now, if you want to remove it, you can remove it in fact, right? Even from here. If you want to remove a message queue, how do you do it? Within the like program, you say MSDCTL and IPC RMID. Whereas from here also, you can remove it in fact, IPC RM, right? And then minus, followed by what it is right now, message queue. So minus Q. Then Q ID equal to 3, let us see. So it has done something. Now you ask it to display. You don't have anything, right? So this is how you can remove the message queues or anything for that matter. By giving IPCRM space minus M to remove the shared memory, minus S to remove the semaphore, and then give the corresponding ID. ID that is actually displayed like this. Not the key value, but the corresponding ID that is returned by like a get function, get system call, or whatever. So that is about some of these things. So the commands try to practice IPCS and IPCRM to do all that. And then the other things, I hope you must have followed what we have discussed today, right? Message queues, client server model, both like a one way as well as both ways. Something called half duplex, full duplex kind of analogy you can always think of. So hope you have understood. Like next class we have to look into semaphores. That is the last IPC mechanism. Any questions or any issues from your end? Are you all there?
Yes, sir.
Okay, so we'll close the session for today. I will upload the. I'm also uploading. Almost most of them are there, right? Only programs maybe as and when we are talking about these programs also will be shared. So try to practice. Next week, semaphores, and after that, the only thing that is left out is RPC, remote RMI actually, remote method invocation. We'll look into that. We don't know when the exams, almost syllabus is by and large, we are completed. The thing is now from your end you have to start preparing and then demonstrating your skills and all that. Okay, so today we'll stop the session there.
Sir, what about NP lab?
Huh?
NP lab.
Lab. What is your doubt regarding lab?
Lab manual will be given, sir, or we should be doing it.
Lab చేయాలి మీరు basically you have to maybe ఇంకా department has to decide actually because labs are not open and you are not coming to the college. So once you come there, like there's some list of experiments that are given to you. That is only an indication. So how much knowledge should you get? In general, if you are following all these classes properly, and then understanding all these things, trying out these programs in the Linux machine or whatever, that knowledge is in general good enough even for the lab. Right. The only thing is you have to do all of that. Right. So shell programming, and then all those things are there. Shell programming, and then system calls using C language, and then Java we have seen, right? All of that. So basically, if you follow this class properly, it is going to address everything, even with respect to the lab also. If you are not doing well here, there also it will be difficult. Is it okay?
Okay, sir.